All right, so welcome on this one, which covers on characteristics of broadband networks. Excuse me on the quality. I think you can see it's sunlight behind me. But anyways, I'm going to continue. So this covers broadband or characteristics of broadband networks. Um, Remember broadband networks, the way in which they're designed to transmit um, high data rate or high speed connectivity, reliable connectivity, secure connectivity, as well as scalable connectivity. So the performance of the broadband networks which I introduced earlier, or their performance, the performance as well as the effectiveness are mainly determined by the characteristics which I'm going to talk about or address in detail. But I'm gonna stick on or cover mainly two of them, and then I'm going to continue onwards with the other ones, right? So they're determined by these several characteristics that directly influence things like user experience as well as network efficiency. So the first characteristics of any broadband network, whether it's DSL cable, satellites, whether it's fiber or 4G or 5G or cellular networks, doesn't matter. All these broadband networks have a characteristic of high data rates, which means that data is being transmitted at very high speed over a network that would represent or indicate to us that how quickly information is moving from one point to the other. And these data rates or high data rates of all the broadband networks are usually measured in kilobits per second, megabits per second, gigabits per second, as well as terabits per second in special cases. So kilobits per second would usually have thousands of bits per second. Megabits would have millions of bits per second. Gigabit would have billions of bits per second. So imagine you'd have like data rate of like 15 megabits per second. That means you have like 15 million uh, bits per second being transmitted. Maybe you have also, let's say, 2 gigabits per second, which would imply that there's like 2 billion bits per second of information being transmitted at every second, right? So these high data rates, enable things like faster download and upload speed, right? So when you download something, remember the download speed would be the speed at which data is being received from the internet to your device, right? That's downloading. When you're downloading, you're receiving information from the internet mainly to your device, right? And the many cases of these downloading, which like happens through streaming. When you're streaming a video, essentially downloading, receiving information from the internet to your device. It could be downloading files on the internet, or it could be loading websites as well. And then when it comes to uploading, essentially you are receiving, or no, rather, you are sending information or data from your device to the internet. And there's a couple of cases when you do so. Things like uploading videos, for example, on YouTube. Things like sending emails with attachment, or video conferencing, that's uploading as well. It's another case of uploading, and you would be concerned with upload speed as well, right? As well as cloud backups. Those are example or cases of uploading, or where high data rates matter. So many broadband systems or many broadband networks actually offer, mainly, you remember, DSL technology or DSL networks, which offered, when you classify them, you classify it into asymmetric DSL, symmetric DSL, as well as very high bit rate. Now, when you specifically focus on ADSL, right, which is asymmetric, most broadband networks offer asymmetric speeds, whereas on the other hand, fiber networks often offer like symmetric speed, which means you have equal upload and download speeds. When you have asymmetric download speeds, uh, that means you have faster download speed compared to upload speed. So that's where the high data rates matter in terms of download speed as well as upload speed. Now they also support um, HD or 4K streaming, or several other things. So remember, HD would require like, excuse me, for HD would the streaming would require maybe somewhere around 5 to 10 megabits per second. But on the other hand, 4K streaming would then require, let's say, at least 25 megabits per second or more, right? So those are the data rate, right? When you're downloading large files, you need high data rate as well. Cloud computing depends on um, high data rate, as well as operating IoT devices or multiple devices all at the same time. All of that requires high data rate, right? So high data rate, without them, uh, these are several problems, things like buffering or lag, or it could be poor quality. All those things can occur if you have low data rates. So high data rates are the first characteristic of these broadband networks that I've dealt with in the past, and I'm going to continue to deal with in the near future, right? Now, the next characteristics of interest when it comes to broadband networks is a low latency, right? Now, remember, low latency or latency itself would be, there's a certain delay when you send the data and receiving a response. That is to say, what is the time that it takes for, data to travel from the source to the destination and back to the source. So we're interested in that time. That is the latency. How long does it take for data to, be transmitted from the source to the destination and back? Understand? That's latency. And latency compared to your high data rates are usually measured in milliseconds. Latency is usually measured in milliseconds, so it varies per what do you call per broadband network, right? For DSL, it's different. For 4G, it's different. For satellite, it's different, right? So you have typical values of like for fiber, 1 to 10 milliseconds, which is actually equivalent to 5G. 5G also have similar latency to fiber networks. You have 1 to 10 milliseconds, but when you look at cable internet, has like latency of 10 to 30 milliseconds, whereas 4G has like a latency of 20 to 50 milliseconds. However, satellites, on the other hand, have high delay, right? Very high latency, especially geostationary satellites. They have like a latency which would range somewhere between 500 and 700 milliseconds. So that's a very high latency. But when there's low latency, it means there's faster data transmission. So we want a low latency. That's a key characteristics of broadband network studies of interest to us as we move along, right? So this latency, or this feature of broadband networks of having low latency, actually is important for digital applications such as gaming. We can think of video calls or as well, or video conferencing, right? So when it comes to gaming, latency, is critical to reduce things like lagging, to because remember, in gaming you need real-time player interaction, right? You need fast response to actions. You need reduce lag as well. So when you have high latency in gaming, there's a problem, which means there's usually delay. You have rubber banding and poor gaming experience. So those are some of the issues that high latency can cause. But latency is of key interest. Low latency is of key interest to us. When it comes to video conferencing or video calls, um, latency is critical for several things. Namely, you want a smooth conversation when doing a webinar or video calls or whatever, or when it's remote work, remote collaboration. You want a smooth conversation. You want minimal delay between the interaction between the users of the network, as well as you don't want any communication breakdown as well, right? So that's what latency, a low latency provides when it comes to video conferencing, right? You don't want any breakdown in communication. You just want a natural communication as much as possible. So latency is really critical, especially for these digital applications that you'd find which require real-time interaction, right? So next, I'm going to continue with more characteristics of broadband networks, right? Like reliability, scalability, bandwidth, security, and many other characteristics. So see you next time. Thank you.